Okay, in this video, we're going to learn about two-way frequency tables and relative frequency. There are 4 pieces of information we have to talk about before we start. And the first one is what is categorical data. Excuse me. I already have the definitions written in because I tend to write a little bit slower than you. So this way, it's already there. So you can copy it, pause the video if you need to. So there's categorical data and there's numerical data. Obviously, numerical data has numbers. We've talked about that before. So what we haven't really talked about is categorical data. So categorical data is data with only one variable, and it does not, so it's without numerical order. So for example, if we're doing an observation on, let's say, hair color, and we make some quick observations. So we want to categorize those that have black hair, those that have blonde hair, and because I don't have a whole lot of space, let's just call the other category other. And we notice that maybe 6 people have black hair versus 10 people that have blonde hair and maybe 3 that have another color hair. So here is one variable. All we did was talk about hair color. That's just one variable. And there's no real numerical data or data numerical order. Yes, there are some numbers, tally marks, but basically there is no relationship between the number of people and the color of hair they have. So it's not like we're trying to find 2 variables and force fit them together. So categorical data is a great situation where you would make bar graphs. So we might say, okay, those that have black hair, whatever that number is, so we would say 6. And then those that have blonde hair, we would make another bar, so that one would have to go up to 10, and then another category. So bar graphs usually represent categorical data. Okay, the next definition that we need to know is bivariate data. So now we are talking about 2 variables, and they may have a relationship or they may not have a relationship. And we've seen this with scatter plots. So let's say that I am, again, making observations between the number of ice cream sales that occur versus the weather. So let's call that temperature. And so those are my 2 variables. And let's say that we see 120 ice cream sales when it was 82 degrees outside. And then another day there are 45 sales when it's only 32 degrees outside, and so forth. So you can see how they differ, because here we were just talking about the one variable, hair color. There was no real numerical data, no relationship. But here we have 2 variables, and they may or may not have a relationship. So in order to find that out, we typically would make a scatter plot where we would put temperature and then ice cream sales, and we would plot these points somewhere on here, and we would look to see, is there a correlation? Could we make a line of best fit through those data points to make predictions? Okay, so 2 things we have so far: categorical data and bivariate data. So in a two-way frequency table, we're going to be using the bivariate data, but rather than making a scatter plot, we're going to be making something else called a two-way table. So a two-way table is a way to display information. It shows the number of occurrences for each of the combinations of categories. And again, pause the video if you need to get that copied. So let me draw a picture. So let's say that we did an observation and we were recording people with cats and dogs. And so here is how we're going to display it using a two-way frequency table. So trying to draw this as neat as possible without using my smartboard. All right, so we want to observe those that have a cat and those that have no cats. Maybe I'll make that plural. And then here we have those that have dogs and no dogs. So we make an observation that 5 people that we survey have cats and dogs. and 4 people have no cats, but they have a dog. So then we have 3 people that have a cat, but no dogs, and maybe, let's say, 8 that have no cats and no dogs. So when we have bivariate data, when we have 2 pieces of, or 2 variables that may or may not have a relationship, and there are combinations of occurrences, then a two-way frequency table is the best way to show our results. So very last here with our definitions is what is actually a frequency table. So the frequency table is a result of a two-way table. It's a ratio of the specific amount of time something occurs or will occur. And that ratio can be written as a fraction. It can be written as a decimal. It can be written as a percent. And sometimes that ratio is also called a probability, because we know that probabilities are fractions, decimals, and percents as well. So sometimes this word ratio can be replaced with the word a probability of a specific amount of times something occurs or will occur. So let's use this example because, again, relative frequency starts with a two-way table. So I'm going to copy sort of what I started with, but instead of putting my tally marks in there, we're going to turn those tally marks into ratios. So this was cats, this again was no cats, this is dogs, and this is no dogs. Now, when you calculate relative frequency, it can be based on the total number of people that you observed, or it could be based on those that just had cats, or it could be based on those that didn't have cats. It could be based on those that had just dogs and those that didn't have dogs. But in this case, we're going to do our relative frequency on the total amount of people. So that's going to be important, and you'll understand more about that in the examples that we do in class. So let's say that I notice that 5 out of, let's see, how many people are there total? 5, 10, 14, 15, 16, 17, 18, 19. Perfect. Something I can divide evenly. There's 20 total people. So those that had cats was 5 out of 20. So then I would change that to 20%. Those of the people that I observed that didn't have cats was 4 out of 20. So that would be 20%. Whoops. This was 25%. This is 20%. This would be 15%. And here I would have 40%. So this relative frequency was calculated with the total number of people in mind, and so I basically just took these 5 tally marks and divided it by 20. 4 divided by 20, 3 divided by 20, and 8 divided by 20. So let's look at an example of how to fill in a two-way frequency table from just a summary of an observation. A survey of 6th graders at Belvedere Middle School, struggled there for a minute, found that 300 students own a cell phone and 250 of those students also own an MP3 player. A little outdated, I guess. There are 250 students that do not own a cell phone but own an MP3 player. 125 students do not own either device. So let's go in and fill in what the obvious pieces of information would be. So this 250 is pretty obvious because that's how many students own a cell phone. So under my cell phone category, and also own an MP3 player, so that's going to go right here. So that piece of information, have a cell phone and an MP3 player, so that's an obvious piece of information. We also know that there are 250 students that do not own a cell phone but do own an MP3 player. So that would go here, no cell phone but do have an MP3 player. And my total, that's pretty easy to do too, because 250 plus 250 is going to be a total of 500 people that own an MP3 player. All right, so what else can we fill in? We know 125 students do not own either of the devices. So that would go here, 125, no cell phone, no MP3. which means that I can calculate this total by adding those together. 375 people do not have a cell phone. So now I have to work on the other numbers here. So let's see, where can we go next? Well, we know that there were 300 people totally surveyed. So if I take 300 minus the 250 that have a cell phone and MP3 player, that's going to leave me with 50. So now I know there are 50 that have a cell phone and no MP3 player, which is going to make this category add up to 300. And now that I know that that was 50 and this is 125, that's going to mean that this total is 175. And here's how I can check my answer to make sure I did it right. These two totals should be the same as the sum of these two totals, which is 675. All right. A survey of 8th graders at Liberty Middle School found that 342 students play a sport, and 268 of those students also take a foreign language. There are 206 students that do not play a sport but are enrolled in a foreign language class. 113 students do not play a sport or are enrolled in a foreign language class. Complete the two-way table. So let's take a peek at this one. So what is our obvious information? So 342 students play a sport, and 268 of those students also take foreign language. So we know that the 268 do both, play a sport, and are enrolled in a foreign language. And we know that there are 342 students that play a sport total. So that's going to go down here in my play a sport total category. So if I subtract those two numbers, 342 minus 268, that's going to give me 74. So I know that 74 play a sport but are not enrolled in a foreign language. So what else do I know? There are 206 students that do not play a sport, but are enrolled in foreign language. So I can put my 206 here. There are 113 students who do not play a sport or are enrolled in a foreign language class. Awesome. This is going to be simple. All I have to do is add those together to get 319. And then add these together to get 474. Add my not enrolled in a foreign language class, and that gives me 187. And then again, my quick check. Those should add up to the same sum as this column here, which they do because they both give me 661. Okay, so now let's calculate some relative frequency, because I think we've gotten pretty good at filling in our frequency tables. So to calculate the relative frequency of the total number of students, we're going to divide each section. So each one of these 4 sections would get divided by, since we're looking at total number of students, they would all be divided by 661. So if I wanted to know the play a sport enrolled in a foreign language, I would take 268 and divide it by 661. If I wanted to know don't play a sport and are enrolled in a foreign language, I would take 206 divided by 661. If I wanted to even know the total number of students enrolled in foreign language, just foreign language, has nothing to do with sports or not, I could even take the 474 and divide it by 661. And again, I could do that for each of these categories. If I divide this cell by 661, I'm going to get 100%, because that would be the total number of people in my observation. Okay, to calculate the relative frequency rows, so now we're talking, I want to find the relative frequency based on this row here. So maybe I wanted to know, what is the relative frequency of those, I can't read my table anymore, what is the relative frequency of those that play a sport enrolled in a foreign language compared to those that are enrolled in just a foreign language? So I would divide these numbers by 474. Or if I wanted to know these cells based on the total number of people not enrolled, I could also use 187. Or in this case, I could use 661 if I was basing it on the total. So honestly, when I'm finding the relative frequency by rows, it's going to depend on the question. So any of those totals could be used. And likewise for columns. So it's going to depend also on, what the question is specifically asking. So if I was calculating it by columns, I could use 342 if I was basing it on those that just play a sport, or 319 if I was playing it on those that don't play a sport, or again the 661. So it all depends. So let's look at a specific question. What is the relative frequency if students that take a foreign language and play a sport? So take a foreign language and play a sport. So play a sport and take a foreign language, so that would be 268, to all of the students taking a foreign language. So all of those taking a foreign language would be this number here. So I would have to take 268, divide it by 474. So there's my ratio. I can reduce it. I can turn it into a decimal. I can also turn it into a percent by just moving my decimal 2 places. And that's it. Just need to stop the video.